They will not take that long.
I'll just go take the ball.
I'll just start asking every.
No.
What does C mean?
Alright.
What letter in the alphabet is that?
C?
We are going to talk about L'Hopital's rule today.
Low hospitals.
Well, hospitals. Let f and g be functions that are differentiable on an open interval from a to b containing c except possibly at c itself. Assume that g prime of x does not equal 0 for all x in a and b except for possibly at c itself, and the limit of f of x over g of x as x approaches c produces the indeterminate form. So a lot of that stuff in the beginning are just stipulations that make this theorem possible. So don't get lost in all the words. All right, the important part about L'Hopital's is that you are taking the limit of f over g, and it gives you the indeterminate form.
Weston, why is your phone making noise?
Parker, my phone doesn't even make noise anymore. It makes this loud vibrating noise. It's quite disgusting to hear, actually.
No idea what that noise was. In DeMars's class.
Yes, exactly.
All right. So if this is possible, you're taking a limit, you get the indeterminate form. L'Hopital says that the limit as x approaches c of f over g is the same thing as the limit as x approaches c of the derivative of f over the derivative of g. All right, now let's talk about the indeterminate form. We used 0 over 0 a lot at the beginning of the year. That is the indeterminate form. So if you get 0 over 0, you had to do one of these other methods: factoring, fractions, distributing, conjugate, squeeze theorem, one of those guys. Now you have L'Hopital's. So instead of doing one of those, you could use L'Hopital's. You also have another indeterminate form. It is infinity over infinity. So do you remember what method we used when we plugged in infinity? Spit method. Very good. So instead of using the spit method, you also could do L'Hopital's. All right. So L'Hopital's will work for a lot of different limits. Now, that being said, sometimes our old methods are easier. So sometimes the old methods are easier to solve for limits instead of using L'Hopital's. But sometimes L'Hopital's is easier, and L'Hopital's kind of gives you a one-trick method to solve a lot of different problems. Yep. All right. The important thing is L'Hopital's is not quotient rule. All right. It is not a It's not a derivative. It's a way to solve a limit. All right. So it is not quotient rule. And on your homework, I threw in a couple quotient rule questions to make sure you are actually reading the question and not just blindly working stuff. So you're actually reading it and knowing what it's asking.
If it's asking, like, will it say, hey, do this in quotient?
It'll ask for a derivative. And then the L'Hopital's, it'll be a limit. So like,
Oh, that says, it doesn't
Yeah.
say it just says.
so 1 you would use L'Hopital's, but 2 would be quotient rule because it's derivative. So they look really similar if you're not paying attention to the symbols. What's up?
Can you tell me how L Hospital turns out to be L'Hopital's? It's French.
What he said.
We do English math. I'm more English than French.
It's a French dude that invented it. That's why it's French.
So why are we doing it in America?
You're only allowed to do American math?
Yes.
No.
Hey, if you could form that into like a better ball shape, that'd be kind of nice.
I probably could.
Because the corners are quite pointy. Alright, it's fine. Continue!
All right.
Sorry.
Or just take time, you know, like.
If you get the indeterminate form, you can use L'Hopital's, but on the AP test, you have to show 3 different things to get credit. So if you're doing the FRQ, you need to show it's continuous. That almost happens for almost any theorem you use. So when we did IVT, or if we're doing L'Hopital's and we got some other theorems, you have to state continuity. So you have to say that your function is continuous. The other thing you have to show when you're doing L'Hopital's is that you have the indeterminate form. So you do actually have to state that your limit equals 0 over 0. And you have to write the word L'Hopital's. You have to tell the graders that you're using L'Hopital's. So you need to show it equals 0 over 0, and you need to write L'Hopital's on the free response. Multiple choice, they don't grade your work on multiple choice. That will just get thrown away. But on the free response, if you don't put those things down, you'll lose points. All right, so let's get into some problems now. What is the first thing you try when you are solving a limit? Direct substitution. So we are going to first directly sub in my number. So I get 2 times 3 minus 5 over 3. So what's 2 times 3? Yeah. 6 minus 5, so 1 over 3. And if you get a number, that is your answer. All right, so if you get a number, that's your answer. You don't have to do anything special. All right, let's talk about 26. All right, if you plug in 2,
It's 0 over 0.
it's 0 over 0. All right, so at the beginning of the year, if you got 0 over 0, you had to try one of the other methods. What method would you use on this one? Yep. And what does the top factor out to be?
Oh, x minus 5, x minus 2.
Yes, good. X minus 5, x minus 2. And what cancels?
X minus 2.
The x minus 2's. And then when you cancel out the x minus 2's, then you can try to directly substitute again. And when you directly substitute, you get negative 3. All right, so that's how we did it at the beginning of the year. So now let's talk about using L'Hopital's. Hold on. Same problem. Just draw a line.
Oh, man.
Yep.
Oh, what?
All right. Using L'Hopital's. All right, so first thing is when you plug in, we kind of wrote it over there, but I'm going to write it again, showing that it equals 0 over 0. And then you write that you're using L'Hopital's. And we're going to rewrite the limit. So you still have to write the limit as x approaches 2. And we're going to take the derivative of the top and the derivative of the bottom. What's the derivative of the top?
2x minus 7.
What's the derivative of the bottom?
X. Negative X.
1.
Oh, yeah.
And then after you take the derivative of the top and the bottom, you're going to directly substitute again. So 2 times 2 minus 7,
Negative 4. No, negative 3.
negative 3, and then over 1, so it's just going to be negative 3, and you get the same answer.
Is that it?
Hmm?
Why didn't you teach us this earlier?
Because you didn't know how to do a derivative earlier. So you could factor, but you also could use L'Hopital's. The nice thing about L'Hopital's is it works for all of the indeterminate forms. Factoring only works if you can factor. And if you look at 27, if you look at that, because you get 0 over 0, just to save you some time. And you're like, I don't remember how to factor a 4 term. So if you don't remember how to factor a 4 term, then factoring is not going to work for you. All right, or if the 4 term was not factorable, then you would use L'Hopital's. All right, so I'm going to use L'Hopital's. So I've got the limit as x approaches 2. What's the derivative of the top?
Negative 1.
1. And the derivative of the bottom?
9x cubed squared.
9x squared.
12. 12x
Yeah.
plus 1.
Plus 1. Okay. All right, so the derivative of the top and the derivative of the bottom, the limit is still in the front, and then we're going to try to directly substitute. So you have 1 on top, 9 times 2 squared, minus 12 times 2, plus 1,
36 minus 24 plus 1.
which is
13.
13.
Great job. Wonderful.
It's not bad. Forgot the 1 over.
All right, go over to 28.
This French guy knows this stuff.
Yeah.
Yo, get him, get him.
Oh, I need my pencil back. Come on.
All right,
Right back at you.
on 28. Your first step is to directly substitute, and when you directly substitute, you get 0 over 0. Now, what method would you have to do if you had trig at the beginning of the year? Do you remember?
No. Wait, hold on. The unit circle?
Which one of those guys?
Squeeze.
Yes, squeeze theorem. And y'all hated squeeze theorem. Do you remember the squeeze theorem?
No.
Well,
Really.
that's fine because we can use L'Hopital's now. So L'Hopital's will work on any of these guys. So if you don't remember squeeze theorem or you don't want to do squeeze theorem, we can do L'Hopital's. So I'm going to write L'Hopital's.
Cosine of 6x.
All right, so good. So on this one, what rule do you have to use?
Derivative?
Chain rule. Wait.
Chain rule.
Yeah, chain rule.
And the trig derivatives.
Because you got an inside and an
Still
outside.
gotta use chain rule?
What is the inside?
6x.
6x. All right, so like Weston said, the derivative of sine is cosine. Yep, cosine of 6x times
Times 6.
6. Because the derivative of the inside is 6. What's the derivative of the bottom? 1. And then you're going to directly sub in 6 cosine of 6 times 0. What is 6 times 0?
0.
0. What's cosine of 0?
0. What?
No.
What?
1.
1.
Oh, shoot.
All right, so 0 is right here on your unit circle over there on the right side. And that coordinate point
6 over 1.
is 6 times 1.
So it's 6. So it's 6 over 1.
Okay, next one.
I don't get
I was ready to hump
I don't
this
either.
thing at you.
All right, 29. When I plug in 0, what do you get on top? 0. What do you get on bottom?
0.
Do you?
One.
Dang it.
1.
What is e to the 0? 1. What's 0 divided by 1?
0.
0. Do you have to do anything else?
No.
What's my answer?
0 and 1.
Yeah, just 0.
Oh. 0.
So direct substitute first. If you do not get the indeterminate form, it's not a L'Hopital's. You only can use L'Hopital's for the indeterminate form. Otherwise, you're going to get the wrong answer. If you start L'Hopital'sing all your limits, you're not going to get them right. You only can do it on the indeterminate form. All right. So now let's talk about if you're approaching infinity. If I plug infinity in here, I get ln of infinity over infinity. All right, which is the indeterminate form? So what we did at the very beginning of the year is we did spit method. Which one is bigger, ln of infinity or just regular infinity? Just regular infinity, because ln levels off. Do you remember how the graph like levels off there? So it doesn't get very high.
He's so paranoid. He doesn't tell me.
All right, so you ready?
Yes.
Focusing. ln of infinity is the spit. And what is 1 over infinity?
0.
Yes.
Great job, Trey. Is that the answer?
Yep. Now, I want to show you.
Whose PlayStation notification?
I want to show you what it looks like using L'Hopital's. So that was doing the spit method. All right, so this guy right here was the spit method, and you're just looking for the biggest thing. All right, if you're doing L'Hopital's, we have to take the derivative. What's the derivative of ln of x? 1 over x. What's the derivative of x? 1. All right, so when you directly substitute, you get 1 over infinity divided by 1, which is just, 0 over 1, which is just 0. So you'll get the same thing using L'Hopital's. It's just a different way of doing it. All right, let's look at 31. All right, 31, I'm going to plug in negative infinity. So negative infinity squared, e to the negative, and then I'm going to plug in negative infinity. What happens when you square the negative? It becomes positive. And what happens with the double negative on the bottom? It becomes positive. Now, what's bigger, infinity or e to the infinity?
E
E to the infinity. So that means this infinity here is spit, and we are left with 1 over e to the infinity, which is going to be
Just 0.
0, because 1 over infinity is 0. So once again, that's the spit method. All right, let's talk about the L'Hopital's method. That was me, obviously. All right, what's the derivative of the top? 2x. On the bottom, the inside is negative x. So when you're doing the derivative, bless you, the derivative of e, bless you,
Thank you.
you have to write it the exact same way. E to the negative x times by, what's the derivative of the inside?
It's just 0.
Negative 1. The derivative of the exponent,
It's just the answer 0.
okay. So I'm going to put that negative in the front. This guy?
Yeah.
So when you do the derivative of an e, you write it the exact same way. And then the derivative of the inside, which is the negative 1, is a chain rule.
Okay.
Okay, so when I directly substitute now, infinity in, I get negative 2 times infinity over negative e to the infinity. So I'm still getting infinity over infinity. I'm still getting the indeterminate form. And this happens a couple times on your homework. So if you get the indeterminate form, you're going to L'Hopital's again. All right, so you can keep doing it until it works. So we're going to L'Hopital's again. So I'm going to take the limit as x approaches negative infinity. All right, so we're L'Hopital'sing that guy right there, the one I circled. What's the derivative of 2x? 2. What's the derivative of negative e to the negative x?
1. No.
Negative e to the negative x times negative 1. All right, so on top I have 2. On bottom, the double negative is going to turn positive, and then the double negative in the exponent will also turn positive. So you get 2 over e to the infinity,
0.
which is going to be 0. All right, so if you really notice on that one, L'Hopital's was much more of a process than doing the spit method, but I wanted to show you how you sometimes have to do L'Hopital's again to get the right answer. All right, and then the last one, how would I solve number 32?
Trig derivative.
That's chain rule.
Chain rule and what other rule?
Trig derivatives.
Yes, trig derivatives
Quotient rule.
and quotient rule.
Yep.
Because it's being divided, it is not a limit. So for quotient rule, what is the low function?
X.
All right, the derivative of the high function
6. Cosine is 6x.
times, yep,
6 or cosine.
minus, okay, so low d high minus high, what's the high function?
Sine 6x.
Good. Derivative of the low, and then all over
X squared.
x squared. So what's going to happen is this x and this 6 are probably going to get moved to the front. 6x cosine of 6x minus sine of 6x all over x squared. And there's not really a whole lot else you can do with that. You can't cancel anything, and it doesn't really simplify farther. All right, questions?
Oh.
Okay, so no, you have to do your homework. No way.
Please, we just feel like I understand it. If I can show you how to do 3 Ds like
He's like 6'6".
No, you have to do 9 questions.
Alright, Preston.
All right, be careful on the homework because some of them are just direct substitution. Some of them are just regular derivatives. You are not allowed to copy, though.
I got you.
No, you're not allowed to copy. You sit down at your desk and do them. 9 questions.